In this section, we'll be solving systems of equations. Systems of equations are scenarios in which you have two or more equations, typically with two variables, sometimes more, but there's only one combination of answers that will answer each equation in the system correctly. So what we're looking at in the first problem is the equation y equals 1/3 x plus 4, as well as the equation y equals 2x minus 3. So there are two equations in this system, and there's only going to be one combination of an x value and a y value that will satisfy both equations, make them both true. To solve via graphing, we're simply going to graph both of the lines and find their intersection. The y-intercept for the first line is at positive 4. So we start at the center of the graph, go up 4, and put our first dot. The slope of this line is 1/3, which means that for every one space we go up, we need to move 3 over. And slopes are a pattern, so you can move up 1 and over 3 as far as you can go on the graph. Now, because we need our lines to be exact so that we can see the exact solution, I recommend continuing the slope pattern in the opposite direction. So before we went up 1, right 3, now I'll continue in the opposite direction, going down 1 and left 3. When you're finished, you can draw a line through the dots. This line represents all of the xy solutions of the first equation. To find the one spot that will set where the x and y values will answer both equations correctly, we also need to graph the second line. The second line has a y-intercept of -3. So we would start at the center, go down 3, and put a dot. It has a slope of -2, which if we want to make a fraction is like -2/1. So from the intercept we go down 2, right 1. Now obviously if I continue going down and to the right, I'm not going to run into the other line. So I'm just going to start going in the opposite direction now. Instead of down 2, right 1, I'll go up 2, left 1. And I'll continue that pattern until I come to this point where the two lines will intersect. After I mark that point, simply draw my line. And the final part is I want to know the coordinates of that point. This point is 3 spaces to the left, or -3 on the x-axis, and it's 3 spaces up, +3 on the y-axis. Let's look at the graph in the top right and try to solve this system now. The intercept of the first equation is -3. The slope is 2, which means up 2, right 1. We can continue that pattern until we get as far as we can go in this direction, and then we'll move in the opposite direction, which is down and left. Our first line goes through all of these points, and we need to know which one is the solution of the system, so we'll graph the other line as well. It has a y-intercept of +4 and a slope of 1/4, which means up 1, right 4. It looks like our solution is right here, so we can draw our second line and label the coordinate pair of our solution, which appears to be 1, 2, 3, 4 on the x-axis and 5 on the y-axis. 4, 5. The bottom left system. The first equation is x minus 4. It has a y-intercept of -4. And remember, if there's no number in front of an x, it's like an invisible 1. So the slope of this line is 1, which is graphed just like the fraction 1/1. We move up 1 and right 1. We'll do that until we run out of space, and then we'll continue in the opposite direction by going down 1 and left 1. This is our first line. The second line has a y-intercept of positive 7 and a slope of negative 5 over 6, which means down 5 and right 6. This point will be our solution. The coordinates of this point are 6 over and 2 up. So 6, 2. The last systems that we'll graph, the first line, 2/5 x minus 7, has a y-intercept of negative 7 and a slope of 2/5. So we'll go up 2, right 5. Then we'll continue in the opposite direction, going down 2 and left 5. Draw a line through and graph the next line, which has a y-intercept of negative 1 and a slope of negative 1 over 5, which means down 1, right 5. Our solution is right here at the edge of the graph. The coordinates of this solution are 10 spaces to the right and 3 spaces down. So 10, negative 3.